let's try to find the reduced row echelon form of some more matrix. The first one, you can actually do this rather easily by hand, but if I were to do it in Python, I can just copy and paste my old code, and then let's see. My matrix then is going to be just 1, 2, and then 0 and 3. Okay. Yeah, so the reduced row echelon form is just going to be the identity matrix. And this is because, well, you can kind of see that you can divide the bottom row by 3, so you get 0, 1, and then you subtract 2 of this from the first row. So the first row then become 1 and 0. So the rank of this guy is going to be 2. Now for the second one, this is already in reduced row echelon form, so there's actually nothing to do here. We have the leading one here, and then the rank of this guy is going to be 2. Now for the third one, let me actually just do the same thing again. My matrix here is going to be a 3 by 3 matrix, and then the entries are going to be, let's see, 1, 2, 7, and then 3, negative 1, 0, 3, negative 1, 0, and the last one is going to be 1, 0, 1, 1, 0, 1. So here is my reduced row echelon form. I only have 2 non-zero rows, so the rank of this guy is going to be 2 then. So the reduced row echelon form here is going to be 1, 0, 1, and then 0, 1, 3, and then all 0. So the rank of this guy is going to be 2. And for part D, I'm going to just simply copy and paste here. Notice that for part D, this is mostly the same as part C. I only changed the numbers in the last column. So from 701 to 123 here. So let me actually just go ahead and make that change. So I'm going to have 1 here, 2 here, and then 3 here. Okay, so the reduced row echelon form here is just going to be the identity matrix. So I have the identity matrix here. So the rank of this guy is just going to be 3. And similar to the matrix that we have earlier, we actually are going to see more examples that use these matrix in the later lecture. Okay. And let's now do the last one. I'd like to find the reduced row echelon form and the rank of this big matrix. Now then, well, I can technically kind of type in all these numbers and ask the Python to find the rank of to find the reduced row echelon form and the rank for me. But I could also write a program to generate this matrix for me here. Notice how my matrix, this is a 10 by 10 matrix. And if I were to write it in Python, because, well, Python start index with 0. So for the first row, it's going to be I equal to 0, I equal to 1, until I equal to 9. And for the column, I'm going to have j equal to 1, j equal to 0, j equal to 2, and so on. J equal to 1, and so on. And the last one is going to be j equal to 9. And notice that I can write out the entry of the matrix Aij. The entries in row I and column j here is just going to be 10i plus j and then plus 1. Well, when I is 0 and j is 0, I'm going to have, let's see, 0 plus 0 plus 1, so I get a 1. When I is 1 and j is 0, for example, I'm going to have 10 times 1 plus 0 plus 1, so that's really 11. Of all the 12 here, if I equal to 1, j equal to 1, I'm going to have 10 plus 1 plus 1, and that's 12. And for the last entry, if my I and j are both equal to 9, I'm going to have 90 plus 9 plus 1. So that really sums up to the 100 here. And if I were to write this in Python, let's see. Let me actually first generate a 10 by 10 matrix then. So let me actually first just generate the just a simply zeros matrix. So I'd like my matrix to be 10 by 10. So I'm just going to have 10, 10 here. And let's see what my matrix A look like for now. Yeah, so this is my 10 by 10 matrix and the entries are all 0. So now, if I want to change this entry, so I'm gonna have my I be the row, I be the column and j be the row. So I'm gonna have for I in range. So I would run from 0 to 9, so the range would be range 10. And then my j, I'm gonna have j is going to be in the, let me see. So j is gonna be in range of 10 as well. But I need to change this to column. Okay. So I'm gonna need the entry of my matrix. I'm gonna need aij to be, let's see, 10 times I plus j plus 1 like we said earlier. So let's see what we get. Okay, this is indeed the matrix that we are looking for. I'd like to find the reduced row echelon form for this matrix, so I can just now use the command. It's gonna be simpy.matrix, and then matrix A, and then reduced row echelon form. Okay, so this is the reduced row echelon form of the big matrix that we see earlier. Notice that the rank is only 2. I only have 2 non-zero rows, and the leading one is in the first and the second column, and that corresponds to column 0 and 1 according to Python.